Okay, here's our video on conditional probability. So conditional probability is just like if we were doing a dependent event. So let's just go over an example. Let's say we had a bag of marbles. We had 2 blue, 3 red, and 5 green. So let's go over an independent event. Let's bring that up. So let's say we want to know what's the probability of picking a blue marble and then, let's say, a red marble in an independent event. So in an independent event, we replace, right? Whatever we take out, we're going to replace. We're going to put back in. That's an independent event. So the probability of picking a blue marble, there's 2 blue marbles, and there's 10 total. And the probability of picking a red marble will be 3 out of 10. So the probability is 6 over 100. So in an independent event, we replaced the marble. Whatever marble we picked, we replaced it. Now in a dependent event, we do not replace. So let's look at this with a dependent event. Let's say we want to know in a dependent event, do not replace, the probability of picking, let's say, a red, then a green. So let's look at again, we have 3 reds, 5 green, and 2 blue, so we have 10 total. Probability of picking a red the first time would be 3 out of 10. Probability of picking a green would be 5 out of 9, because we didn't replace a marble, so the odds change. So here we have 15 over 90. Now, with a conditional event, in a conditional event, you have 2 or more of the same type. So let's say we had a probability of picking a red, then a red. So here we have 2 of the same type. So this is a conditional event. So in that case, the probability of picking a red is still 310 the first time. But the second time, now that we would only have 2 reds left, and we didn't replace a marble, so it's 2 ninths. So that would be 6 over 90. So let's go back to the bag of marbles. We had 2 blue, 3 red, 5 green. Let's do another conditional event. Let's say I wanted to know in a conditional event, which we know is dependent, probability of getting a blue, then another blue. So that's conditional. And why is it conditional? Because you have 2 of the same item, blue. So let's look at our marbles. There's 2 blue, 10 total. Probability of getting a blue the first time will be 2 out of 10. Now we don't replace, and we already used the blue, so there'll be 1 blue left, and the probability will be 2 out of 90. Okay, let's look at another example using a standard deck of cards. Okay, so in a standard deck of cards, there's 52 cards in a deck. And there's 4 of each of these cards. There's 4 2s, 3s, 4s, 5s, 6s, 7s, and so forth. These cards here, the Jack, Queen, and King, are called the face card. And the Ace is a special card. Sometimes it could be the low card, and sometimes it could be the high card. So we have 52 cards in a deck. So in a dependent event, we have our decks of cards here. Let's say we had a deck of cards. And let's say the probability of picking a Jack. We have a Jack. So the probability of picking a Jack would be 4 out of 52. Okay? Now, in a dependent event, this Jack I don't replace. So now there's 51 cards left in this deck. So remember, with dependent events, we don't replace. Okay, so let's just say, get this deck of cards out of the way. Let's say we wanted to do a dependent event where we wanted to find the probability of getting a Jack and then a King. So in a dependent event, we don't replace the card. So the probability of getting a Jack is 4 out of 52. Since we didn't replace the cards, the odds change. Now there's only 51 cards. So the probability of getting a Jack will be 4 out of 51. And that would be our answer, 16 over 2,652. So let's look at it if it was a conditional event. So we know conditional events are also dependent events. It's conditional because we have 2 of the same item, Jack and Jack. So the probability of getting a Jack is the same, 4 out of 52. since we already have a jack, or assuming we picked a jack, now there's only 3 jacks left. So the probability of picking another jack will be 3 out of 51. And the answer will be 12 over 2,652. So remember, in conditional events, you have 2 or more of the same item, the same type of item, like 2 jacks, 2 queens, and so forth. Now here's a question that we had in the homework. Let's say we had these people running for student council, 8 boys and 4 girls. They're running for student council. Let's say I wanted to know what's the probability of picking 2 boys. Or we should say the probability that 2 boys are elected. Okay, so let's write this out. So we know, let's say we want to know the probability of picking a boy and another boy. Now this is a dependent event, we know, because if we're picking 2 boys, we're not going to replace 1 boy if we want 1 boy to be president and 1 boy to be vice president and so forth. So we know it's dependent, and we also know it's conditional because we have 2 of the same items. So the probability of picking a boy the first time will be 8 out of 12. So this is conditional. We know we already picked a boy, so now we only have 7 boys, and the odds do change there. So this will be 56 over 132. And this could be reduced to 14 over 33. So remember, in dependent events, you don't replace. You don't put back. The odds change. And conditional events are dependent events, and they're conditional when you see 2 or more of the same item, like boys and boys in this case. Or when we did the marbles, red and red. So that's conditional probability. Great job.